Discuss about how to perform exploratory factor analysis in SAS. The confirmatory factor analysis will be covered in a separate session. What are the things that I am going to cover in this session? First, I'll do a correlation check of the variables. I'll also talk about how to use a procfactor for doing factor analysis, and then also I'll also cover the options available with procfactor in doing factor analysis. Make sure you have gone through my video on factor analysis theory. The name of the video is factor analysis, wherein I have covered the theory on factor analysis before going to this video. To illustrate this particular topic, I'm going to use a data set. Let me show you the data set. The data set has information on the school students. It's about the performance of the students in class. What are the variables available to us? We have mother education, father's education, family income, score in English, mathematics, science, social science, natural science, and vocabulary. Okay. After factor analysis, I am going to build a model based on the performance of the student. I am going to categorize student into good and bad. Okay. With some criteria, I have categorized with student type 0 and 1. 1 is good and 0 is bad. But student type variable, which is a binary variable, is not going to be used for factor analysis. Okay, so that is going to be used in the future regression model. That's the reason why I have this variable in my data set. But this variable is not going to be used for factor analysis. Okay. What is our objective? Well, the objective is that when we will do a regression model, I'm going to do a logistic regression model. Once the factor analysis, I have the factors in place, I'll regress student types with all the other variables, right? So that's my regression equation is going to be. How many independent variables I have? From mother education to vocabulary, I have 8 independent variables, and student type is my dependent variable. Okay. Now we have 8 independent variable, and there seems to be some kind of a redundancy in the data. So instead of using 8 independent variable, we can get down to a very few number of factors. The objective of this session is how to reduce a number of variables. We have 8 variables here to a very few number of factors, and then use these factors for the regression model. Got it? First thing we will do is to see the correlation. We will do the correlation check first. I'm using all the variable except student underscore type. As I said, that particular variable is not going to be used for factor analysis. Let us go to okay. You can see that there is high correlation among variables. High correlation between vocabulary skills and English. Makes sense. has correlation between vocabulary ability and then social science. Hence, we can conclude that there is some level of redundancy in our data. And when we have redundancy in the data, we need to use factor analysis to come up with a few number of factors out of this large number of variable. We don't have a large number of variable, but we can of course reduce the number of variables from 8 to a very few number of factors. Procfactor is the SAS proc that is used for factor analysis. Procfactor data, name of the data, and then in var you mention all the variables that you want to use in factor analysis. This is the simple form of procfactor syntax. There are options available. We will use the options later. Let us run the simple, the very simple version of procfactor. You will have so many things in the output. Not everything will be covered in this session. The important things will only be covered. You can see a message that 2 factors will be retained. So procfactor says that out of these 8 variables, you can make these 8 variables into 2 factors. Okay, we can group the 8 variables in such a way that we will only have 2 factors in place. We never asked SAS to group them into 2 factors. It's SAS by certain criteria. Well, the criteria is Vinay's criteria. You can read the SAS manual to get to know more about this criteria. Using that criteria, SAS tells us that 2 factors will be retained. Okay. Let's go to the box factor pattern. You can see there is factor 1 and factor 2. Automatically we have 2 factors in place directly given from the algorithm. Now how do we know that? If you remember my session on factor analysis, what I told is that each and every variable is a linear combination of the factors. Okay, let's take this variable mother's education. So mother's education is a linear combination of factor 1 and factor 2. The coefficient, okay, this is the estimated coefficient. The estimated coefficient for factor 1 is 0.41 and that with factor 2 is 0.69. Similarly, for father education, the estimate, the coefficient of factor 1 is 0.5 and the estimated coefficient for factor 2 is 0.69. Okay, we can write it down like this: mother's education equal to 0.41 factor 1 plus 0.6 factor 2. Similarly, we can write such equation, this type of equations, for all the variables that we have used. Now remember one thing. If you remember what I talked, what I taught in the factor analysis video, the theory part I'm talking about. Out of the two coefficients, look at the one which is having a higher value. Okay, usually one of the coefficient will be significantly higher than the other. This coefficient for factor 2 is significantly higher than coefficient for factor 1, right? So 0.6 is greater than 0.4. Okay, hence mother education is explained more by factor 2 and less by factor 1. Got it? Hence mother factor 2 is contributing more towards explaining mother's variation in mother's education. So factor 2 is the latent factor associated with mother education. Now let us go back to the result and see where factor 1 is contributing more. If you see English, the coefficient for English score is 0.77 for factor 1 and minus 0.23 for factor 2. Hence, factor 1 is contributing more to the English score than factor 2. Similarly, mathematics. Factor 1 is 0.77 and factor 2 is 0.17. The coefficient for factor 1 is significantly higher than coefficient for factor 2. Hence, factor 1 is contributing more to the mathematics score. Okay. So there is a trick here, how to club variables, right? We have got factor 1 and factor 2. So how to club variables into separate factor? Okay. Wherever you have higher coefficient, just mark it. First variable mother education, I'll mark this one. Second variable father education, factor 2 coefficient is higher, again I'll mark the second one. And then family income 0.6 against 0.4 for factor 1. So coefficient for factor 2 is higher. Hence, and no other cases, right? In no other cases you have factor 2 having higher coefficient. So only first three variables are the ones where the coefficient for factor 2 is higher than coefficient for factor 1. Hence, the first three variables, mother education, father education and family income, can be clubbed together. Okay, so that come under the factor 2. Okay, in the last 5 variables, in all the cases, the coefficient for factor 1, you can see it, is higher than the coefficient for factor 2. Hence, we can club these 5 variables into factor 1. Okay, so that's how we group the variables. Factor analysis is all about grouping variables into one single factor, right? Okay. Remember, this is exploratory factor analysis, so we have no clue, no hypothesis to start with. We do not have any knowledge or very little knowledge about how the variables actually behave, or if there is any pattern, if at all there is any pattern among the variables that we have used. Okay, the SAS algorithms suggest us that we should be taking only 2 factors, but we have the option of selecting the number of factors. How do we do that? We can use the nfactor criteria. Okay, so when we use the nfactor option, we can mention there how many factors do we want to be there in the result. Okay, if we want to enforce it, if you don't want to enforce it, we just want to explore it, we can just let the algorithm find it out for us. Okay, that's about exploration. I told, right, procfactor is used for data exploration purpose. So we start with no option, then we go on with options, and then keep changing the options to see if there is more pattern coming out from the results. Okay, let me give 3. Let me see what happens if I ask SAS to give me 3 factor instead of just 2. Let me see the factor patterns. You can see in the output there are 3 factors. Remember the way we group the variables. I talked about how to group variables, right? Now, when you have 3 factors, look at the coefficient which is the highest among all the factors, all 3 coefficient of 3 factors. For the first variable, it's factor 2 coefficient. Second variable, again, it's the factor 2. Similarly, in the third variable also, it's the factor 2. Okay, and then I don't see any valuable thing happening by enforcing 3 factor. The reason is because most of the pattern in the data is being explained by factor 1 and factor 2. Factor 3 is useless, because except natural science, where not even natural science, yeah, I don't see even any place there is no variable where the coefficient of factor 3 is the highest among all 3 coefficient, right? Can you see? Yeah, I can't see that is there anywhere. So factor 3 doesn't add much of value to our analysis, right? So we can try it out, like we can keep increasing the number of factors and see what is happening. Okay, that is the way we do the analysis. As I told in the very beginning itself, that we don't go with any hypothesis, any knowledge. We just keep on exploring. So number of factor is 2. We could see that if we have 2 factor, that is enough. That explains our data set. The next thing that we will study is how to plot a scree plot. To plot a scree plot, we use the option scree, SCREE. Let me run this. Well, what is scree plot? Well, it's nothing but it's a plot of the eigenvalues, and then this particular plot is used to find out the number of factors that should be retained. SAS suggests us that we should be using 2 factors, but we are not sure of it. I mean, because it's an algorithm at the end of the day. How do we select the number of factors to be retained? Look at this plot. Look at this plot. It keeps decreasing, then it become flat, right? So there is an elbow-like structure. There is an elbow-like structure of this plot. Wherever we see the elbow, after the second eigenvalue, you can see that all the other eigenvalues are lying on more or less on the same line, right? The elbow-like structure is there at the second eigenvalue, and that is the way you select the number of factors to be retained. Okay, so we will retain only 2 factors. Now, had it been the case where if this third eigenvalue, right, it would have been somewhere here, and the elbow-like structure would have been there at the this eigenvalue, then we would have retained 3 factor instead of 2. But here it's there with the eigenvalue 2, hence we will keep only 2 factors. That is the use of scree plot. The next thing that we will study is about rotation, a factor rotation. Let's go back and see the factor pattern. There are 2 factors in place. Factor pattern gives us the coefficient that is estimated by using the estimation algorithm, and we find out that which variable is related to which factor, right? We group variables based on the factor loadings. We call it actually factor loading. Instead of coefficient, we actually call it factor loading. Rotation is a method using which we can discriminate between the factor loadings better. So what do we mean by that? Well, the factor loading for the variable father's education is 0.5 for factor 1 and 0.6 for factor 2. There is not much of a difference between them. Rotation helps us discriminating the factor loading. That means making it the distance between the factor loading for one factor and the other factor, making it maximum. Okay, so that it can be clearly distinguishable. Okay, what it essentially does inside the algorithm is that it orthogonalizes the data set, orthogonalizes the factor scores. Okay, what is orthogonalizing? That means it makes sure that there is a 90-degree or the 2 data sets are perpendicular to each other and not very correlated to each other, and ensuring that the factor loadings are entirely different and there is a distance maintained between them. Let us use it, it will be more clear.